Hey guys, so in this question, you have three similar conducting plates, and these three similar conducting plates are arranged as shown in figure. So these two plates are separated by 3D. These two plates are separated by a distance of d. Area of each plate is given as A, and a charge of Q is given to the middle plate. So, and if you notice in this diagram, these two extreme plates are grounded, right? So from all of this condition, we need to calculate what will be the potential of the middle plate. What will be the potential of the middle plate over here, right? Okay, so we'll be solving this question from what we learned according to properties of conductors, but later you learn that these questions can also be solved by using the idea of capacitors. But right now I'll be solving them using what we have learned and using properties of conductors, right? Okay, anyways, so with that being said, let me start off solving this question. So let me draw your three conducting plates, and these plates are, I'm not drawing the thickness, so these are your three conducting plates. Okay, this distance is given as 3D. This distance is given as 3D, whereas this distance is given as D. Okay, and now a charge Q is given to the middle plate. A charge Q is given to the middle plate right now. And this is grounded. This is also grounded, right? Okay, so from this, let's try to gain some ideas first. So because we are grounding them, it's not necessary that the charge on these has to be equal to 0. So I can have a charge X on this. I can also have a charge Y on this, right? Okay, the first idea now is, let me consider a Gaussian surface this way. Let me consider a Gaussian surface which passes through the thickness of this plate. So let me consider this Gaussian surface. So hopefully the diagram of this Gaussian surface is clear. This portion is passing through the thickness of this plate. So let me exaggerate the thickness if you need. This is like your plate right now. These are your plates. And your Gaussian surface is passing through the thickness. So your Gaussian surface is passing within the plate. Within the plate, right? Okay, so now what's your flux to the Gaussian surface? So this is a standard idea we have used in the derivation when we dealt with parallel conducting plates. Field at all these points have to be zero. Field at all these points have to be zero. Field is parallel to this surface. Field is parallel to this surface. So your flux to this Gaussian surface has to be equal to zero, which means charge enclosed has to be also equal to 0, right? And what all surfaces are enclosed right now? This surface is enclosed. Charge on a conductor should only be on the surface. So the surfaces which are enclosed here is this, and this, right? The total charge on this is Q. And okay, and you'll see that X charge has to be only on the inner surface over here, and here Y charge will only be on the inner surface. So let me also discuss why you'll have X and Y charge on the inner surface. So the first idea we'll get from this is X plus Y plus Q has to be equal to 0. So that implies X plus Y has to be equal to minus Q. The sum of charge on these two plates has to be equal to minus Q. Now, why is that so? So this we got from the idea of Gaussian surface. And so now I can reduce one unknown. Instead of writing an unknown Y, I can write this Y as nothing but minus Q minus X. I'll write this Y as minus Q minus X, hence reducing our unknown, right? So now let me discuss this point as well. So I'm saying that the charge on the outermost surface here has to be equal to 0. Why should the charge on the outermost surface be equal to 0? Okay, so we know that potential, because this is grounded right now, potential of this conductor has to be equal to 0. Similarly, because this is also grounded, potential of this conductor also has to be equal to 0. Which means when I go from infinity towards this point, when I go from infinity towards here, I should have no change in potential. Your potential at infinity is also equal to 0 only. And when will I not have any change in potential if field over here is 0 right now? And field in this region, field in this outside region is being created by the outside plates only. The field in the outside region is being created by the outside plates. So because field in the outside region has to be 0, your charge on the outer surfaces has to be 0 over here. So this is a very important idea. When your outermost plate is grounded, that means your potential of the outermost plate has to be equal to 0. And potential of the outermost plate can only be 0 if field in the outside region is 0. Field in the outside region is being created by the outermost surfaces. Field in the outside region is created by the outermost surfaces. So that means charge on the outermost surface has to be equal to 0, right? So when we assume that we have X charge and Y charge on these outermost plates, I know charge on the outermost surfaces has to be equal to 0. So X charge will go to the inner surface, Y charge will go to the inner surface. And that's what I've made use of in Gauss law, right? So hopefully this idea is also clear. Okay. Now, we still have one unknown left. We need to find out what this value of X is, right? And to find the value of x, we'll make use of this idea that when I go from here to here, when I go from the first plate to the last plate, your change in potential has to be equal to 0. So when going from first plate to last plate, change in potential has to be equal to 0. So I'll write down change in potential as we go from one plate to another plate, right? So for that, we need the field value in between. So let me write down the field values in between. Here the charge is x, so charge on this surface has to be equal to minus x. Here charge is minus q minus x, so charge on this has to be equal to q plus x. We also know it should be q plus x because sum of the charges has to be equal to q. Okay, so how will field be in the region between them? So let me assume x is positive. So that means field here will be in this way. And let me write this field as E1. So what will be the value of E1? Value of E1 will be equal to sigma by 2 epsilon naught due to this surface. Sigma by 2 epsilon naught due to this surface. Both the fields will add up. So your field in the first region will be equal to x by a epsilon naught. X by a epsilon naught. And the potential difference. So when I'm going from plate 1 to plate 2, so when I'm going from plate 1 to plate 2, your change in potential will be equal to minus E bar dot D bar. So that will be equal to minus x by a epsilon naught into 3D. Minus x by a epsilon naught into 3D. So this is your decrease. So what does negative sign over here mean? That is when I'm going from plate 1 to plate 2, potential decreases. Potential decreases by this much amount, right? So this is your change in potential from 1 to 2. Okay, what about change in potential from 2 to 3? So let me continue that over here. So when I'm going from plate 2 to plate 3, let me assume q plus x is positive. So my field here will again be in this direction only. So what will that field value be equal? Let me write that as E2, and that E2 value will be equal to q plus x by a epsilon naught. It is sigma by 2 epsilon naught due to this. It's sigma by 2 epsilon naught due to this. So both the sigma by 2 epsilon naught will add up. You'll get q plus x by a epsilon naught. So what will be a potential difference then when I'm going from plate 2 to plate 3? So because I'm going in the direction of field and the field is uniform, it's minus E bar dot D bar. So that will be equal to nothing but minus q plus x by a epsilon naught into D right now, right? So what's your total change in potential from when I'm going from plate 1 to plate 3? Your total change in potential when you're going from plate 1 to plate 3 is minus 3 dx by a epsilon naught. Minus 3 dx by a epsilon naught. Then minus of q plus x into d by a epsilon naught. And the total change in potential from 1 to 3 has to be equal to 0 because potential of the first plate is equal to 0. Potential of the third plate is also equal to 0. So this is the equation now we'll be using to find out what the value of x will be equal to, right? So now let's solve this equation. Okay, so solving this equation, we'll now find out what the value of x will be equal to. So our value of x will turn out to be, so minus 3dx minus qd minus xd has to be equal to 0. So d will also get cancelled. So we'll get minus 4dx to be equal to plus qd. D will get cancelled. So x will be equal to minus q by 4. We got the x value, and x value has to be equal to minus q by 4 right now, right? So now we know all the charges. So this, once we know x, we know the charge on all the other plates. So now let's focus on what we need to calculate. We need to calculate what's the potential of the middle plate, right? I know potential on this plate is 0. And we also went from plate 1 to plate 2. So when you went from plate 1 to plate 2, your potential decreased by this much amount, right? So I also know what your potential on plate 2 should be. So let me now write the charges as well. Let's go about it from there. So now from this, I'll say charge on this plate is minus q by 4. Charge on this plate will be plus q. On this surface will be plus q by 4. So charge on this surface has to be equal to 3q by 4. And charge on this surface has to be equal to minus 3q by 4. Right? So these are your charges on all the surfaces. Now I know this is grounded, so potential here is 0. I know this is also grounded, so potential over here is 0. Now I need to find potential of the middle plate, right? So now we know field direction will be this way. This will be your direction of field. And what will be the value of that field? That value of field will be equal to sigma by 2 epsilon naught twice. So it's sigma by epsilon naught. So it's q by 4a epsilon naught. That will be your field value. And when I'm going from here to here, I'm going against field. So potential will increase. So your delta V will be equal to minus q by 4a epsilon naught into 3D. And now if I'm going in this direction, if I'm going in the direction which I'm showing, I'm going against field. So that will be equal to cos 180. And this will now be equal to V final minus V initial, which is nothing but V of the middle plate minus V of the first plate, which is equal to 0. So from this, we get V of the middle plate to be equal to cos 180 is minus 1. So this minus sign gets cancelled. We'll get this value to be equal to 3QD by 4A epsilon naught. So we'll get potential of the middle plate to be equal to 3QD by 4A epsilon naught, right? So hopefully this question made sense. See you guys in the next question.